Welcome back, everyone. This is the methods question that 98% of students get wrong, and it's one of my favorite exam questions because we assess so many skills in the single question. We assess your algebra skills, your ability to sketch functions, factorizing, quadratics, simplifying, sort of algebraic fractions. There's so many different skills we like to assess here, and it's why this question is kind of popular, or this theme of question is very popular. Also, because of all the little skills you need, it's one where most people get it wrong. And it's not that difficult. A lot of people will see this question and think, this question's super easy. And I think that's part of where some of the mistakes come from. So, the first thing people look at is I've got this denominator here of x minus 2. And one of the thoughts is like from our hyperbolics unit, well, we're going to have some kind of asymptote. And this function actually has 0 asymptotes. And I'm going to explain why. Okay, when we have functions where I have algebra on my numerator, algebra on my denominator, the first step really is look for common factors, but we're in the process of factorizing. So we check for common factors. There's no common factors on my numerator or my denominator, so now I'm going to start by factorizing. I recognize I have a little squared power here on my x, so I have some kind of quadratic. So we think about our quadratic factorizing toolkit, so to speak. And hopefully most of us, now that I've sort of prompted some of these thoughts, can realize, well, this is going to be difference of two squares. Well, if I factorize using difference of two squares, I wind up with x minus 2, x plus 2. If it's confusing why that is the factorized version, please comment. I can do a whole separate video explaining how to factorize difference of two squares. Now, once I factorize my numerator, I can write my denominator, and I can start canceling out. I cancel out my x minus 2, and that also cancels out with my denominator. When I say cancel, the real answer is, anything divided by itself gives 1. It doesn't go to 0, it goes to 1. That's just a point I like to make 1,000 times. So, I get this function. And once we get this function, it seems like, ta-da, we are on the right track. It is simply x plus 2. I have a linear function, and I'm just going to go sketch a straight line. And you are 99% correct if you think that is the case. And this is sort of the bit where I said 98% of students get it wrong. A lot of people get to this step, they realize it's linear, and they sketch, and I'll point out where the error mainly is. Okay, so we sketch our linear function. It's x plus 2, right? I just simplified, I cancelled. This is my resulting function. If I sketch my function, let's get myself my axes here. So I get myself my axes, I get my straight line. If we do a quick little bit of solving here, I'll do it in green. My function, my y-intercept is going to be positive 2, and my x-intercept, if I let f of x equals 0 and solve, I'll just show that. If I let f of x equal 0 and solve, I wind up with x equals negative 2 for, well, it's my head's covering, sorry, but that is my x-intercept right there. So after I identify my x and y-intercepts, I want to come down and I want to draw myself my straight line. So if I draw myself my straight line, something like this, and I can label my points, here is going to be 2, here is going to be negative 2, and I have myself my straight line. I've labeled my x and y intercepts. I should label my axes too, right? Let's make the whole thing official. And I guess the final step normally is to write out my equation, okay? My function is equal to, we're going to write out our original function, that is x squared minus 4 over x minus 2. So that's my function. I've got my straight line. I've labeled everything. Happy days, full marks. The issue is, I have no asymptotes. However, if we think about my original function, this is what I'm sketching, right? If I think about my original function over here, my original function is x squared minus 4 divided by x minus 2. This means that if I just think about what happens when x equals 2, well, if x equals 2, I wind up with a situation where on my denominator, I get 2 minus 2, I'm dividing by 0. Now, normally with hyperbolics, that creates an asymptote. It doesn't create an asymptote in this case. However, there is a value that x can't equal, and that value is at 2. So I need to basically represent that on my graph with a little open circle. Okay, so I'm going to put a little open circle here to show that when x equals 2, I wind up with a situation where I have like a break in my function. Now, to find the coordinate point of this little circle, I'm going to simply substitute f equals 2 into this equation here, and you can see if I put f equals 2 into there, I get 2 plus 2, which gives me a value of 4. So the coordinate points for this here is 2, 4. And I represent that with a little break, that little open circle over my line to show it is all the values along that pink line except for the exact value basically of 2. Now, a little wrinkle we get with these questions is oftentimes it asks us to state the domain. If we write the domain for a question like this, if I write my domain, well, my domain is simply going to be all real values of x. X is all real values, except x cannot equal 2. That is basically how, I'll pull this on a little bubble and I'll put this somewhere else so we can all see that nice and clear. That is going to be the domain for my function, essentially, okay? It's not an asymptote, it's just one specific point on my line that my function can't equal. And because of the tiny little intricacies with my domain, with the fact that I have to have this little open circle on the line, this is why so many people make a mistake somewhere along this process. And even though it seems like we're sketching a linear function, it's sort of a linear function with a twist. So let me know in the comments, do you think this question was actually hard? Do you think you would have got it correct? Can you think of any questions that you've seen that are similar, where the math seems easy, but there's always a tiny little mistake you make somewhere that means, or it stops you from getting 100% on the question, or stops you from getting all the marks available? Let me know what you think, and I'll see you guys in the next video.